Hi, I'm Melinda Rose.
And I'm Laura Marshall.
And this is Light Matters for November 2nd, 2011.
In this week's 5 Minutes to Enlightenment, flooding in Thailand hits the optics industry, biomolecules show their true colors, a merger of plasmonics and nanophotonics could power tomorrow's computers, NASA wants to make tractor beams a reality, and we reveal the winner of our iPad 2 contest.
A number of optical components OEMs are having to find alternate sources after one of their major suppliers in Thailand said it would be closed through the end of the year due to severe flooding. The floods, which began in July after unusually heavy monsoon rains, have killed nearly 400 people, submerged 4 million acres, and encroached on areas of Bangkok, home to about 12 million people. Bangkok is also home to Fabrinet, a provider of optical communication components, modules, and subsystems, industrial lasers and sensors for companies such as Oclaro, Infinera, JDSU, and Obnext. On October 24th, Fabrinet said that 3.5 feet of water had infiltrated several manufacturing buildings at its Chak Chai campus in Pathum Thani. It expects that production at the facility will remain closed for the rest of the quarter. Several California-based optical component suppliers said the flooding is forcing them to move production to other locations, increase output at other facilities, and use existing inventory, but they still expect some supply chain disruptions. A large percentage of laser diode modules and diode pump solid-state lasers are also manufactured in Bangkok, said laser manufacturer Power Technology, and disruptions in that supply chain are partially due to the fact that up to about 650,000 employees can't get to work. Power Technology of Little Rock, Arkansas announced last week that it is expanding its U.S. production of laser diode modules and other components in response to the flooding and is expanding its inventory.
After years of black and white and false color 3D molecular imaging, events beneath the surface of the skin can now be viewed in their true colors. The novel method, developed at Duke University, uses a modified form of optical coherence tomography to detect and show, for example, hemoglobin's vivid shades of red as it's carried by blood vessels. The modified OCT uses optical echoes to visualize the structure underneath the tissue's surface. The new technique will have important applications, such as visualizing tumor development processes like angiogenesis and oxygen deprivation, according to Dr. Adam Wax of Duke's Pratt School of Engineering. It also could help in detecting eye diseases, especially those that impact the orb's tiny vessels, and may be a way to monitor drug delivery and effectiveness. The team has tested the new system in mice. Oncoscope, a company founded by Dr. Wax, is working to commercialize the technology.
A seamless interface between plasmonics and nanophotonics could pave the way for future light-based quantum computers far more powerful than today's integrated circuit-based machines. The quantum information processing technology would combine metamaterials with tiny optical emitters to make a new hybrid technology that provides a very efficient source of single photons in a broad spectrum, said Vladimir Shalev, Scientific Director of Nanophotonics at Purdue University's Burke Nanotechnology Center. One of the approaches for these hybrid systems uses a nanowire to couple individual photons and plasmons. Another approach is to use hyperbolic metamaterials, which has been demonstrated by Shalev's group. The concept is described this month in Science. Both Wax and Shalev gave presentations on the research in Photonics Media's webinar, The Future of Optics. It is available on demand on photonics.com.
NASA wants to make tractor beams a reality and has awarded a 3-member team at Goddard Space Flight Center $100,000 to study 3 methods of doing so. The goal is to create a concept for corralling planetary or atmospheric particles and transporting them via laser light to a robotic rover or orbiting spacecraft for analysis. The team has identified 3 different approaches for transporting particles, single molecules, or cells using the power of light. Previous techniques, while largely successful, are costly and are seen as having a more limited range and sample rate than an optical trapping system. 2 methods to be studied are using 2 counter-propagating light beams as optical tweezers, which requires the presence of an atmosphere, and employing optical solenoid beams, which relies on electromagnetic effects and could operate in the vacuum of space. The third technique, using a Bessel beam, has never even been demonstrated in the lab, but according to theory, the Bessel beam could induce electric and magnetic fields in the path of an object. The spray of light scattered forward by these fields could pull the object backward against the movement of the beam itself.
We'd like to congratulate Yogesh Saxena, a laser scientist in Instruments Research and Development, an Indian government agency. Yogesh is the winner of our iPad 2 giveaway. Congratulations and thanks for being a regular Light Matters viewer.
If you entered and didn't win, don't despair. We'll be starting a new contest in the next few weeks.
We'd also love to hear from you. Please send your questions, comments, or suggestions to lightmatters@photonics.com. You can also follow Photonics Media on Facebook and Twitter.
Thanks for watching, and remember, it's only 5 minutes to enlightenment.
I guess light matters in my life to the extent that I wouldn't be able to see without it. So it's a fundamental subject. But it also helps us in being able to look at a lot of phenomena on a very short time scale. Light in general helps all of us because of its importance for telecommunications and large bandwidth.
Light affects everything we do. You need photosynthesis to eat, you need something to read with at night, so everything you do every day depends on light. In my work, I teach people how to design illumination systems that can be anything from the headlights on automobiles, which obviously you don't want shining into the eyes of the oncoming driver, to again designing a reading lamp so I can read comfortably at night. So everything I do depends upon light.